In this video, we're going to take a look at 30, 60, 90 degree triangle and 45, 45, 90 degree triangle. First, let's take a look at 30, 60, 90 degree triangle. Let's say you have an equilateral triangle or equiangular triangle. If it's equiangular, then you know that each angle has 60 degrees. And let's say that each side has a length of 1. Let's cut this in half. Now, if you cut this in half, you know that this angle right here will be 30. So you get a triangle that looks something like this. Opposite of 90 will be 1. Opposite of 30 is 1/2. Opposite of 60, let's call it B. And how can we find the length of B? This is a right triangle, so we could use Pythagorean Theorem. So 1 square equals quantity 1/2 square plus B square. So you get 1 equals 1/4 plus B square. Subtract 1/4, both sides, you get 3/4 equals B square. So B is radical 3/2. So we know that B is radical 3/2. Now notice, opposite of 60 is radical 3/2. Opposite of 30 is 1/2. Opposite of 90 is 1. Now based on this triangle, we could find sine of 30. What is sine of 30? Well, it's the opposite over hypotenuse. Remember SOHCAHTOA? So it's going to be 1/2. Opposite over hypotenuse. What about sine of 60? Sine of 60 is going to be opposite, which is radical 3/2 over hypotenuse. So it's radical 3/2. Now what about cosine of 30? Cosine is adjacent over hypotenuse. So it's going to be radical 3/2 over 1, which is radical 3/2. What about cosine of 60? Cosine of 60. 60 is over here. What's adjacent to 60? 1/2. So it's 1/2 over 1, which is 1/2. Now what about tangent of 30? Tangent of theta is opposite over adjacent. So it's going to be 1/2 divided by radical 3/2, which is going to be 1 over radical 3, which is the same thing as radical 3/3. What about tangent of 60? Now, if you look at 60 degrees, it's opposite over adjacent. So it's going to be radical 3/2 divided by 1/2, which is just radical 3. So now we found sine 30, sine of 60, cosine of 30, cosine of 60, tangent of 30, and tangent of 60 by looking at 30, 60, 90 degree triangle. Now let's take a look at 45, 45, 90. And let's call the opposite of 90 has a side of length of 1. And you know that since these two angles are 45, their opposite sides are also congruent. Let's call it x. How do you find the value of x? We could apply Pythagorean Theorem. So 1 square equals x squared plus x squared. So you get 1 equals 2x squared. 1/2 is equal to x squared. So you take the square root, both sides. You get x equals 1 over radical 2. Now you want to get rid of the radical on the bottom, so you get radical 2 over 2. So x, opposite of 45, is going to be radical 2 over 2 if the hypotenuse is 1. So now, what is sine of 45? Sine of 45, you could choose any of the 45 degree angle. It's going to be opposite over hypotenuse, so it's radical 2 over 2. What about cosine of 45? It's adjacent over hypotenuse, so it's radical 2 over 2. Same thing as sine of 45 degree. Now what about tangent of 45? It's the opposite over adjacent, which is radical 2 over 2 divided by radical 2 over 2. So it's 1. Same thing over same thing. By the way, you could also find cosecant of 45, secant of 45, and cotangent of 45 as well. So for example, what is cosecant of 45? Cosecant of theta is hypotenuse over opposite, or the reciprocal of sine of 45. So what is that? This is going to be 2 over radical 2. So multiply radical 2 to top and bottom. You are going to get 2 radical 2 over 2. 2 cancels out, so you end up getting radical 2. So cosecant of 45 degree is radical 2. So you could find secant of 45 and cotangent of 45 using the similar reasoning. So it is very important that you know about the 30, 60, 90 degree triangle and 45, 45, 90 degree triangle.